Welcome. This is another Tactical Technician video from Diagnation. And this case study involves a Ford F550 with a V-10, a 6.8 liter gasoline engine that was reported as having some misfires. Came to me, I did a relative compression. The relative compression was good. Then I decided to current ramp the coils. And as you see on a still screen in front of you, that is a trigger on the red channel. That is a primary waveform from cylinder number one. The blue channel is the current ramp of all the coils, and the green channel is a delta transducer in the tailpipe. And I will explain what's going on here in more detail. First of all, I'm going to show you the firing order, and you can write this down for the rest of the case study, so it makes it easier to understand, because it is fairly a steep learning curve looking at 10 cylinders, being we have a combustion event every 72 degrees of crankshaft rotation. So in front of you, you see two crankshaft revolutions, and all 10 cylinders will fire in 720 degrees. So here is our firing order, is right here. Can you make that out? Hope you can make that out. Okay. That is 1, 6, 5, 10, 2, 7, 3, 8, 4, 9. Take a snapshot of that, because it does help as we talk about the case. Anyway, I decided to go ahead and put a transducer in the tailpipe just to see if I can see something. This is not an easy learning curve. It's a busy event going on. We realize that it's a crowded situation, being that we have a combustion event every 72 degrees, and I'll make it make more sense as I explain. If you look at the red channel, look at the primary ignition triggered on one. In 180 degrees of crankshaft rotation, there's two other combustion events, and then two in each event. So we have to think about this. We have a spark every 72 degrees. We have an injection pulse every 72 degrees when we're firing sequentially. We have an exhaust valve lifting off its seat and sending a pressure pulse down the exhaust every 72 degrees. So think about 72 as kind of our magic number as we analyze this. It's not exact, there's variables. A misfiring cylinder will slow the crankshaft down, and that won't look as neat and orderly as we would expect, but nonetheless we deal with that variable. So we do have a misfiring cylinder right now on this engine. It ended up being a loose connector on fuel injector number one. Yeah, number one. So I'll give you the scoop, and we'll analyze as we watch the pattern. We are also triggered on cylinder one. That is where the red channel. You can see the primary event there on the left side of the lower left side of the scope, and then follow that firing order across till we get back to one in the firing order that you hopefully you took a snapshot of. So as we look at our combustion events, you realize something, that we have a major anomaly right here. You can see that, and in theory what I'll do is that here's bottom dead center for number one, and we can see the two combustion events happen here. So this is going to be busy. So the number one exhaust valve opened about right here, and then there was a couple of pressure pulses going down the tailpipe, and what it looks like is you had one here, and then the misfiring one for one is here. It's not exactly right after the exhaust valve opened for one, because there's another cylinder that opened its exhaust valve a little before one. So basically, as you look at here, you can see the number one cylinder did have a bad injector connector, and once I plugged it in, the pattern cleaned itself up. You can see that. If you look at events, that 72 is our magic number. If we go right here, we go 72 degrees this way, I'll run the cursor to 72. You could see we have a event about right here. So kind of look at that. Again, that's just a downward pulse. It's not real pretty and symmetrical and clean like it's if we had a non-misfiring engine, but nonetheless, just take that into account. That 72 degrees is that amount of degrees where certain event will happen, whether it's an exhaust valve opening, injection, spark, nonetheless. So I'm going to flip-flop and go 72 on the other side. I'll get to about right here. We have another event down here. You can see that right there. I'll go 72 to this side of it. And we see we have another event about right here. That's 70. So nonetheless, just bear in mind that we're using this tailpipe transducer, and it's a very busy event. A 4-cylinder is a lot easier. 6-cylinder is a little more challenging, 8, but when this is a 10, this is probably the most, I mean, obviously unless you get something crazy that comes in, 10 cylinders is pretty challenging when we use this technique. But always think about your combustion events. You know, what kind of degrees are you dealing with? Is it, you know, is it a 90, if it's a V8, it would be 90 degrees. If it was a V6, it would be 120 degrees. If it's a 4-cylinder, it's 180 degrees. And of course, on a V10, it is 72 degrees. So just kind of when you take a snapshot of something and we're using your scope, think about that degree number of where you want to expect something to happen. It's never going to happen perfectly though, because you know the variables involved with misfiring cylinders will slow the crankshaft down, and events won't happen perfectly every time. But nonetheless, you can see that anomaly sticking out. That is a misfire on cylinder 1. This is where about, as I said, where cylinder 1's exhaust valve opened, and then the pressure pulse went down the tailpipe, and the anomaly is created here by the misfiring of cylinder number 1. Anyway, thanks for watching, and take care.